picking up where we left off, quantum mechanics has proven that matter exists at one point as a wavelength of potentiality, and at another point as matter, which is able to be observed at, or not observed, but it's at a finite place in space. And the belief is that the difference between this wavelength of potentiality and actualization is conscious observation. And to better point out this quantum enigma, a physicist named Schrödinger talked about a hypothetical experiment regarding his cat. It's important to keep in mind this was only a thought experiment, as far as I know, or as far as the people who wrote this book think. No cat was actually ever endangered, but Schrödinger postulated that, well, what if, instead of just sending an atom randomly into two boxes, if in one of those boxes I had nothing, say the first box, but then in the second box I have a Geiger counter, which is able of detecting whether or not an atom was in that box, and then attached to the Geiger counter I had a device connected to some poison, where it'd be set up so if the Geiger counter detects an atom, the poison is released. And if the Geiger counter does not detect an atom, then obviously the poison remains in its container. And then he said, well, what if I put a cat in the same box with this Geiger counter and the rigged poison with the Geiger counter? And therefore, if in this hypothetical experiment, if he randomly shoots the atom into the box, he'll be able to tell. It will simultaneously, the Geiger counter will simultaneously go off and not go off under the conclusions of quantum mechanics. So he describes this, or the book describes Schrödinger's experiment. Suppose that before we send in the atom, one of the boxes of the pair is not empty. It contains a Geiger counter that will fire if an atom enters its box. In firing, this Geiger counter moves a lever to pull the cork from a bottle of hydrogen cyanide. There is also a cat in the box. The cat will die if the poisonous cyanide escapes its bottle. The entire contents of the boxes in the atom, the Geiger counter, the cyanide, and the cat is isolated and unobserved. It goes on, the unobserved Geiger counter, which fires if the atom enters its box, must therefore also be in a supposition state. It is both fired and simultaneously unfired. The cork on the cyanide bottle is thus both pulled and not pulled. The cat must be both dead and alive. And as a crude drawing, which is based off a drawing in the book, I made a little sketch and diagram of this experiment, hypothetical experiment. So what he's saying is that instead of just the atom in a box experiment, he's sending an atom into one of two boxes randomly. And the second box, you can see, has a Geiger counter with the poison rigged in the cat. And that if the Geiger counter goes in the first box, then two things could happen. A, the situation A on this side, and B on this side, which is divided by this dotted line in the middle. If it's situation A, you can see the atom is shot into the first box, box number 1. And the Geiger counter has not gone off, the poison has not been released, and the cat is living. In side B, on this side, you can see that there's no atom, where it says right in this box here, box number 1. And then in box number 2 down here, you can see that the cyanide has released the cork, releasing the poison, and killing that dead cat. And according to quantum mechanics, neither of these have happened yet, because both the cat, the atom, the Geiger counter, the mechanism, and the poison are all unobserved. And until then, they all exist as wavelengths of potentiality. And therefore, as the quote said from the book, the atom is both in box number 1 and box number 2. The Geiger counter in box number 2 is simultaneously off and not off, and the poison is both simultaneously in box number 2, released and unreleased. The cork is pulled and unpulled, and the cat, famously, is simultaneously killed and not killed, and living and not living. And this is all like really abstract notions, and Einstein had a problem with quantum mechanics. In this book, they talk about how Einstein, in 1935, he had started the development of quantum theory by pointing out that the theory required an observation at one place to instantaneously influence what happened far away, without involving any physical force. He derided derided this as spooky action. And what he's saying is that according to quantum mechanics, if I observe something in one place, then at another point in space, it simultaneously alters that other space without any physical contact. And there was another physicist by the name of Bell, in I believe the 1960s, so it could have been 70s, I forget a little bit. But he proved that spatiality is not a concrete reality of the external world, which is also very radical thinking. But it's been proven through experiments that something can affect something on the other side of the world, even if they're traveling opposite directions at the speed of light, which is twice the speed of light. They can simultaneously affect each other through quantum mechanics. And that is all things previously mentioned in this video is what is referred to as the quantum enigma. It is the confusing, abstract concepts of quantum mechanics that, as Newton said, they consistently have accurate results, even no matter how weird they are. And then towards the end of the book, they talk about some interpretations of quantum theory. Now, the interpretations can be argued. You can read an interpretation and go, I don't agree with that. Whereas the quantum enigma, the fact that there's no spatiality, or that spatiality isn't a concrete aspect of the external world, and that matter at some point exists as wavelengths of potentiality, all that is in quantum enigma is not really arguable. It's quantifiably been proven. Now, at the end of the book, they discuss several interpretations of quantum theory. My favorite is the many worlds theory, which is talking about alternate realities. And the alternate reality theory kind of says, you don't really need observation, because the big problem with the quantum mechanics is physicists typically hate that consciousness is kind of imposing on physics. And a solution to that came in the 1950s with this physicist named Everett, and he was saying that you don't need observation, that both possibilities happen. They're just in alternate realities, and that when we observe the cat, we happen to observe the reality where the cat is alive, and the atom went in that box. And in another reality, that observer would be in the reality where the atom went in the other box. But that fact is not dependent on observation. Again, this is an interpretation by the many worlds theory by Everett. And he talks about this. So the book says, we can accurately see two measurement problems, two enigmas. We focused on observer-created reality, observation causing, say, the looked-at atom to appear wholly in a single box, or Schrödinger's cat to be either alive or dead. Einstein quibbed that he believed the moon was really there, even when no one was looking, challenged this enigma. A less disturbing enigma is nature's randomness. How does it come about that the atom randomly appears in, say, box A rather than box B? How does the cat randomly come to be in, say, the alive state? Einstein's quib that God doesn't play dice challenged this enigma. With Everett's many worlds interpretation of quantum mechanics, you choose all possible experiments and see all possible results. According to this view, the you in one particular world is troubled by the two enigmas only because you do not realize that every observation and every decision you split and simultaneously exist in a multitude of different worlds. And I've heard the alternate reality theory before, but not in the context of quantum mechanics. And when you listen to it in the context of quantum mechanics, it seems to make a lot more sense. Because the big thing is, well, how does what I do simultaneously or instantaneously affect something way over there? It would have to travel hundreds of light years. But due to Bell's discovery that spatiality is not a concrete part of reality, what I do under quantum mechanics with my decisions can instantaneously affect something, infinity away in an alternate reality based on my decision. And there's several other interpretations that are just extremely interesting. And I found this book informative, thought-provoking, 5 out of 5, definitely. Quantum Enigma. It's an interesting concept. It's well written. It's written in terms that you don't need to have a MD, in physics or in theoretical physics to understand. If you love philosophy, you'll love Quantum Enigma. So I would say go out and buy it and read it. And if not this book, another book on quantum mechanics, because it is all very interesting. So 5 out of 5 for Quantum Enigma by Bruce Rosenblum and Fred Kuttner. Thank you for watching. Please like and subscribe.